Hello students, I am Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. Today it is the third session of the chapter Introduction and Architecture of PLC. We will have a small recap on the previous two sessions. In the first session, we have learned what is PLC. What is the need of the PLC? What are the leading brands of the PLC? What are the applications of the PLC? And then what are the major components of the PLC? Okay. What is PLC? In brief, it is a device. PLC is a device which is used to control the industrial automation. Okay. And next, what are the major components of the PLC? The major components of the PLC are CPU, that is your central processing unit, and you'll be having a memory, you'll be having a power supply unit, and then programming device. Then you'll be having most important thing is I/O modules, and then racks and chassis. These are the main components of any PLCs. Okay. And next, in the second session, we have learned classification of PLCs. Why we need classification? Is it necessary to have so many different types of PLCs? Yes. Why? Because the applications what we are using in today's world. See, the PLCs are used in the small applications as well as the larger applications also. Okay. So, for all the applications, we cannot use the same PLC. If, for example, for the small automation purpose, we cannot use the having I/O ports of having some 1000-2000 I/O modules. The ports it will be wasted and even the cost will also be more. That is why we should have a different classification of PLCs. In the types of PLC we have learned, we are having two types of PLCs. One is modular PLC and the other one is compact PLC. What is modular PLC? Modular PLC, it will permit to have the expansion of modules. In the modular PLC, all the components are independent to each other. All the components we connect manually and will be forming it as a PLC system. So if you want to add I/O modules or memory or power unit, any add-ons you can do in the modular PLC. Okay. And what is compact PLC? In compact PLC, the name itself tells it is a compact one. So all the units, that is your CPU, I/O unit, power supply, everything will be in the single case. So here the inputs and outputs all are decided by the manufacturer. We cannot add on anything to this compact PLC. Okay. So the compact PLC is also called as fixed PLC or integrated PLC. Understood? And next, again we are classifying the PLCs based on the I/O systems and application ranges. Based on I/O systems, we are dividing it as analog system as well as digital system. It is analog I/O modules and digital I/O modules. For discrete signals or for digital zeros and ones, we will be using the digital I/O modules, and for the analog one like temperature, pressure, which are continuous signals, for those we will be using the analog I/O module systems. Okay. Then again, based on application ranges, we have seen different types of PLCs. That is based on using I/O devices. We have already learned that we will be having nano or pico PLC. It will be having less than 15 I/O modules, and those will be using in your PLC trainer kits that we will be doing in the lab and all. And next, you'll be having micro PLCs, small PLCs. This will be using for small automation purposes. And we'll be having the large PLC, medium PLCs in some of the industries, and the large and very large PLCs will be using the very big manufacturing plants like power stations, automobile industries, power industries, chemical industries, etc. Okay. So like this, we have classified our PLCs into different types. Understood? So in today's session, we will be learning about what is relay logic control and what is PLC logic control. What is the difference between the relay logic and PLC logic control? So in this session, the important question is they will ask you compare between the relay logic control and PLC logic control. Okay. Now we will see about relay logic control. Relay logic control. What is relay logic control? And see, we have changed from today all industries they are using the PLC. Why they have changed from relay logic control to PLC logic control? What are the advantages of PLC logic control over relay logic control? Okay, see, in 1968, okay, in the General Motors Hydramatic division, they developed a PLC, right? So before the advent of microprocessors, okay, all the industrial logic and your sequence control, they were used to be performed using this your electromechanic relays and solid state relays, okay, and then your contactors, switches, indicator lamps, okay, electronic and mechanical timers, counters. For all these things, it was having a very elaborate wiring. Okay, all are hardwired by complex and it was having all elaborate wiring. Understood? So after the development of microprocessor, what happened is it also led to the quick development of your PLCs. Understood? Now we will see in detail what is relay logic. Relay logic, here in the diagram you can see here relay logic. Here all relays are connected, okay, and this is very bigger in size compared to your PLC. Relay logic is a hardwired control system using instrumentation, switches, timers, relays, contactors, motors and actuators. Traditional machine and process automation was accomplished by using relay logic. So before PLCs, they were using the relay logic only. Automating a machine using a relay logic, it requires a very elaborate wiring. Also, it needs a more components when to perform your simple tasks. Understood? That is why it is very bigger in size. Understood? Relay logic systems are a network of hardwired electrical components. The relay, it is a fundamental component of this relay logic control. How it works? Relay, it is nothing but a switch. It works by switching electric circuits on and off to form logic operations. That in turn, it will provide process control to the system. So, you can think of this relay logic system as your mechanical computer. It does the computations with ones and zeros by switching relays instead of using your silicon chip. So, in the relay logic control, the fundamental component of relay logic is the relay. Now we will learn what is relay, how it works. So, what is relay here? A relay, it is nothing but an electromechanical device. It is an electromechanical device. The two basic components of the relay are relay coil and relay contact. One is relay coil and another one is the relay contact. These two are the basic components of the relay. The relay contact is used to switch a circuit on or off. Relay, this contact is nothing but your input. Okay, it is used to switch the circuit on and off. And what is this relay coil? It is used to change the state of the relay contact. It acts like an output. Okay, and in the relays we are having different types of relays. Okay, there are the three main types of relays are spring return relays, latching relays and multipole relays. The most commonly used relay is spring return relays. Okay. It is a hardware switching device to control the electrical circuit by using switching logic. See here, this relay, it is just based on zeros and ones. Okay. And why relays are used? Because it allows the electric isolation between your switching circuit, that is your contact, and the control circuit, that is your coil, via using the electromagnetic devices. Okay. So this is called as relay. And next we will see what is PLC. PLC, already we have learned what is PLC. It is a device which is used to control the industrial automation. It is like just like your mini computer. It is a mini computerized industrial control that controls the circuit. In PLC, the basic concept of an electronic controlling system is to simulate the functional logic into different PLC brand softwares for automation. So, it provides a software-based solution. Okay. So, PLC ladder logic. The programming that we are using in the PLC logic control is ladder diagram. This ladder diagram is a very simple programming language. Okay. Relay logic in this PLC, it is a method of formulating logical expressions in order to automate machinery and processes in industrial applications. Understood? So when this relay logic control and PLC logic control both are doing the same work, that is, this is also doing the logical computation and even your PLC is also doing the logical computation, then why today all industries, they are shifting from relays to PLC logic control? Okay. For the controlling electromechanical system, the basic functions of both relays and PLCs are the same in the industries. Then why PLC? What is the advantage of PLC over relay? If we compare the relay with PLC, PLC systems perform better in terms of work accuracy. PLC requires less timing and less wiring, because in the PLC we are doing the programming in the system, so it does not require more wiring and all, and it is also easy to maintain. There will not be much physical work. PLC has more advanced functions as compared to a manual work. Okay. So these are the main reasons why today all industries are shifting to use PLCs over the relays. What is the main disadvantage of the relay? The main disadvantage of the relay is it requires more wiring for performing different functions. The wire, it will be having very elaborate wiring and also more components in the relay. Okay. So that is why today they are preferring PLC over relay. So till now we have studied what is relay logic control and what is PLC logic control. Okay. And now we will see the differences between the relay logic control and PLC logic control. The first one is basic. That is, what is the definition of PLC and relay? Already you know. PLC, it is a solid state computerized industrial controller that performs software logic by using I/O CPU memory. Relay, it is an electromechanical device, switching hardware device. Relay, it is nothing but a switch. It will be having two options, that is whether it will be 0 or it will be 1. Okay. The next one is the function. PLC plays. PLC, it will monitor as well as it will control. It will be doing both the roles in the designing circuit. But in case of relays, it will be having only the role of controlling the design circuit. Monitoring, it is very difficult in case of relay. And working. In the PLC, we can write program. In the relay, we cannot write program because in the PLC, we are using the programming language. So we are having different programming languages like a ladder diagram, okay, instruction list, okay, so many are there. But preferably they'll be using the ladder diagram. We can write the program and we can check the output in the system itself. But in case of relay, we cannot write the program. Operation. PLC is operated on the digital system, but the relays are operated on the analog system. Function. PLC consists of more programming functions, like it will be having timers, counters, memories, etc. But in case of relay, the only function is fault detection function. It is not having any advanced functionalities in the relay. Design. You can easily modify the designing circuit, but in case of relay, the modification is very difficult. See, in the designing means, see, in your program, you can easily change or you can easily design in your system by using the programming language in case of PLC. But in case of relay, if you want to modify your design, you need to go to the floor, factory floor, and there you need to change your design. So it is a little bit more difficult compared to your PLC. IOs. PLC have more capabilities of inputs and outputs, but in case of relay, it does not have more capabilities. See, in PLC, for example, if we want to add any inputs or outputs directly, we can take from the this one programming ladder programming. From there, we can take the inputs and outputs. We can easily add in the program. But in case of relay, we need to go to the floor and we need to fix all the relays. Flexibility. PLC provides more flexibility than the relay. The relay provides less flexibility. Since we are using the programming language, here the flexibility is good in case of PLC. Fault. You can easily find the fault by using the software. Since you are doing in the software, if any error occurs, you can easily trace out the fault and you can easily rectify in the software itself. But it is very hard to find fault in the relay circuit. See here, if any fault occurs, you need to change each and every connections in the relay circuit. Time. The response time of the PLCs are very less. And in case of relay logic control, the response time are very more compared to this PLC. Okay. And next we are having memory. It consists of memory to store the program. In case of PLC, we'll be having the memory. But in case of relay, it does not consist any memory. See here, since we are using the software program, we can easily store our programs. But in case of relay logic, we cannot store in that relay logic this one, relay logic control. And types. There are two types of PLC. One is compact PLC and another one is modular PLC. In case of relays also, we are having different types of relays like electromagnetic relay, thermal relay, induction relay, and also we are having latching relays. Then we are having spring type relays, etc. Okay. These are some of the basic differences between relay logic control and PLC logic control. See, today, if we summarize today's topic, the PLC logic are preferred more compared to your relay logic. Today, almost all industries, they are using the PLC logics because in the relay logic, the main disadvantage is it will be having the elaborate wiring. Okay, and also it occupies the more space. And then the scan time of the relay logic is more compared to your PLC. Okay, so I think now you got the difference between what is relay logic control and what is PLC logic control. Now we'll solve some multiple choice questions based on this. Solenoids, lamps, motors are connected to whether it is analog output, digital output, analog input or digital input. Solenoids, lamps and motors. These are all digital outputs. Second one, an example of discrete or digital control is varying the volume of a music system, turning a lamp on or off, varying the brightness of a lamp, controlling the speed of a fan. So digital signal. Digital means it will be having only two things, whether it will be 0 or 1 or on or off. Then it is turning a lamp on or off. A solenoid is an example of an output device. True, false, none of the above. A solenoid, is example of an output device. It is true. Hard wire control means. What is hard wire control? A. Controlling the hardware with the help of software. B. Controlling the plant with relays, contactors, etc. without any programmable controller. C. Controlling the plant with relays, contactors, etc. with programmable controller. None. The answer is controlling the plant with relays, contactors, etc. without any programmable controller. Sixth, the capability of convention relay systems for complex operations is dash that of the PLC. The capability of conventional relays for doing the complex operations. Okay. The capability of convention relay systems for complex operation is dash that of the PLC. It's poor than B, excellent than C, as good as D, unpredictable as. What is the answer? It is poor than that of the PLCs. Relay consisting of dash. Already we have discussed in the relay. Okay, what are the main components of the relay? A. Only coil. B. Only contact part. C. 1 and 2 both. D. None of this. Relay consists of both coil as well as contact. So the answer is C. 1 and 2 both. Okay. I hope today you understood the topic, that is the main differences between the relay logic control as well as the PLC logic control. Thank you.